Hi everyone, this is going to be a quick explanation of this probability question. So the situation is that we have a coin and we have a six-sided die. They're thrown simultaneously, and then we have a random variable x, which is defined as follows. So if the coin turns up as heads, then x is the score on the die. But if the coin turns up as tails, x is twice the score. So this is a bit complicated. The first thing I want to do is write down all the possible outcomes. So I might do a table. I could have a head or a tail for the coin, and the die, if it were, what does it say? If it coin showed up as a head and then I rolled the die, the score would be 1, 2, 3, 4, 5 or 6. On the other hand, if we had rolled, tossed the coin and got a tail, then the random variable x, we would double that. So we would say the outcome was a 2, a 4, a 6, 8, 10, or 12. Now these numbers here, these are the values of the random variable x. So let's do a probability distribution. The variable x, list them in order, 1, 2, 3, 4, 5, 6. But now there's no 7s, but there is an 8, a 10, and a 12. And what are the probabilities of having these come up? Well, in my original table up here, there are 12 outcomes. There's only one way of getting the number 1. I'll cross that one out. There are 2 ways of getting a number 2, so that's 2 in 12, or 1 in 6. There's only a single way out of 12 of getting the number 3. There are 2 ways of getting a 4, so that's 1 in 6. There's only a single way of getting a 5, that's 1 in 12. There are 2 ways of getting a 6, and then the remainders, there's just a single, so 1 in 12, 1 in 12, 1 in 12. Now that's the hardest part of the question right there, because we've taken the description in words, we've thought about all the outcomes that could occur, and then we have written our probability distribution for x, the discrete random variable. Now we should be able to find the expected value. So here we go. The mean, which is also known as the expected value, is given by the formula sum of x times the probability of x. And so that would be 1 multiplied by 1 on 12 plus 2 multiplied by 1 on 6 all the way across until we finished with 12 multiplied by 1 on 12. That would be a very tedious calculation, so let's use our calculator. Now, I've already been into this one and set the values up. So in list 1, I have the numbers 1 to 6, then 8, 10, 12, and then for each of these in list 2, I've got the probability. You'll see this is a decimal here, but you can see it's the fraction 1 on 12. And then this is 1 on 6, as it should be. So we'll go back to our Run Matrix menu. Now I need to go Options, List, Next, Next, Sum, and I'll use brackets to be sure everything works. And I want list 1, the values in list 1, multiplied by the values in list 2, which was the scores and the probabilities, exactly the way, it almost looks exactly the same as my formula here with sigma notation. And that comes to 21 on 4, which could be 5.25. Let's write 21 on 4. Everything seems to be in fractions. The next part of the question said, find the probability that x is less than the mean. So that number was the mean. So the probability that x is less than the mean, well, that really is the probability that x belongs to the set of numbers 1, 2, 3, 4, or 5. And so that's just going to be those ones added together. What did we end up with there? Well, it alternates, doesn't it? 1 on 12, 1 on 6, 1 on 12, 1 on 6, 1 on 12. Did I start with the wrong one? I think I did. Started with a 1 on 12, didn't it? Yes. 1 on 6, 1 on 12, 1 on 6, 1 on 12. Now, if we just count these as doubles, that's 1, 2, 3, 4, 5. That's 5 on 12, I think. Did I get that right? No, 7 on 12. Having a bad day. 7 on 12 is the probability that our outcome is less than the mean. Now, the last question was find the variance of x. Again, this will be much easier on our calculator. So remember, the standard deviation squared is the same as the variance. And there's two formulas for this. Probably the easier one is to go the score minus the mean squared multiplied by the probability. And it's the sum of all of those things. Now, our first score was 1. The mean was 21 over 4. That would need to be squared. And the probability of that first outcome was 1 on 12, wasn't it? And then we would do that for all of them. Our last score was 12. Subtract the mean, 21 on 4. Try and rub that out, make it neat. 21 on 4 squared. The probability of that one was 1 on 12 as well, and all the in-between ones. Now this is much easier on our calculator. So let's see if we can. Now I'm looking mostly at this formula here. I'll build this up bit by bit. I'll start with a bracket. Now for the random variable x, that was stored in list 1, and the value of the mean is 21 over 4. And I can enter that. So all of the values in my list have had 21 over 4 subtracted. Now if I go back, I can put a squared sign there. Now they've all been squared. Notice that there were positives, so that's good. It's still a list of values. I can multiply by list 2, so that's the part where I'm multiplying by the probabilities. It'll still be a list of values. And finally, I can put brackets around all of this to make sure that the whole thing gets added up with the word sum. And that's the same as my sigma notation. And there's my answer, 497 over 48. Okay, that's it for this question. Thanks for watching.